We're on and Mauricio, and just a reminder, we have a companion slide deck for this talk. And it charts out the major points of each section that we're going to talk about. It also includes an appendix with more information around this topic. So, please check it out using the QR code and the URL below.
Okay, we're going to get started now. So as mentioned, I'm Mauricio. This is An. We're software engineers at Goldman Sachs. So back in 2020, we open sourced Legend, which is the Goldman Sachs strategical data modeling platform. And today we wanted to go through our open source journey. We wanted to talk about the challenges we face, the strategies and solutions we took on with regards to the code base. So we wanted to focus entirely more on the code base side than other aspects of open source. But before doing that, we wanted to give you some context. And although this is not what the talk is going to focus on, we do want to give you a bit of context. So what is Legend and why open source? So our first major key takeaway is when you open source, it's important to have a purpose, right? Because with this purpose, you can justify the cost of open source. When you open source, it's going to take a lot of resources from your company to refactor code, go through the process, et cetera, right? So with this purpose, you would be able to justify that. Additionally, with the purpose, you'll be able to drive your open source project in terms of maintenance and scalability. Additionally, that you can use this purpose to drive your open source strategy. So now, what is Legend? So from a purely marketing point of view, Legend is a model-first data platform that allows querying data easily and efficiently while providing advanced lineage information. So that's kind of like the marketing
Tagline.
Tagline of Legend. But what is it more technically speaking, right? Technically speaking, Legend is a framework using UML compliant elements like class, enumerations, associations. We use these as fundamental building blocks for modeling data. So in Legend, we use a programming language that we built internally called Pure to express these fundamental building blocks. So here you can see how using Pure, we're able to model a gender enumeration and a person class. Additionally, we build elements on top of these. One element that we build is a mapping element, and this mapping element is used to convert one type of element to another, or similarly. So one type of mapping that we have is a model-to-model mapping, which takes an instance of one class and converts it to another instance of a class. So here, we can give you an example, right? We have a doctor instance, and we can convert that to an instance of a person. These model-to-model mappings are important when you have a huge organization and you have like the similar concept, but different sections of the organization model it differently. So you can create these model-to-model transformations to orchestrate the modeling of the two. Additionally, you can also use different data sources. So instead of a model, you can use a relational database. So here we've modeled a Postgres database with a person table. And here, using a relational mapping, what we can do is take a table, person table, and each row will be converted to an instance of a person class. Now, this is a very vanilla use case example, but with the model-first approach that Legend takes on, we allow users to build sophisticated queries using these mappings, and they can do advanced filtering, advanced aggregation. This allows them to query against different data sources that we support. Additionally, using the models that you've defined in Legend, you can also generate those models in different formats. So we support generating in Java, JSON, GraphQL, et cetera, right? And these generations are used in other data pipelines and as well as other applications. So you would model your stuff in Legend, and then you can use it downstream in any other applications. So that prevents you having to code duplicate your models. So if you want to learn more about the different features in Legend, I would suggest you look at our slide deck and our Legend website for more information. So now back to our purpose. What was our purpose in open sourcing Legend? Our purpose was we thought that Legend could solve many complex problems in the finance industry, and we wanted to help push the industry forward. We also wanted to create an ethos of collaboration within the finance industry and use Legend to interact with more third-party tools. So before open sourcing, we figured we had a lot of challenges. Two of those challenges are, first, we had a lot of proprietary features. So an example is we referenced a lot of transformations against our in-house data lake infrastructure, which is proprietary to Goldman Sachs. We also did some code generation against Slang, which is used by our strats team for trading. So we couldn't really open source that part. Additionally, we had a huge code base with one singular module, which makes it extremely difficult to take that and just dump it outside. So in today's talk, we're gonna talk about how we address these challenges. Specifically, we're gonna focus on Legend Studio, which is the web IDE of Legend. And that's why we've labeled this talk open sourcing an in-house monolithic web application.
But really, we hope that what you take away from this talk will be applicable to just about any project or any setup that you have, or and it helps you to open source stuff in the future. So we talk a lot about open sourcing so far, but are we really on the same page about what it really means to open source the code base? Well, in simple terms, right? When I think about it, it involves splitting the code base into two parts: the open sourceable part and non-open sourceable part, and somehow cleanly separate them in a way so that you can bring the first part out in the open and then make it public on a GitHub repository or something like that. But that's really simplistic, and it's too contrived. What you really need to think about is the functional aspect of the act of open sourcing. So when you open source an application, essentially you're open sourcing a version of the application, a smaller version of the application that works, right? Because this version doesn't include all the proprietary features. Let's call this the core. And then the remaining of the code that you cannot open source is probably something that builds upon this core, but contains like proprietary features that you cannot open source. Let's call these non-core. And your job as part of somebody who open source is to cleanly separate these two pieces, like we said. But think about this, right? The core is like a seed of an avocado. You just go over, scrape off the flesh, take out the seed, extract it, give it to other people so that they can plant more avocado trees. And that is the essence of open sourcing. Now let's look at this as in a more procedural manner, right? So what are the steps of open source that we have so far? So you start out with a giant core. Essentially, all your code base is the core at this point. And then you use different refactoring technique to gradually extract and cleanly separate the core from non-core. And then you clone this core to a separate repository and make it public on a platform like GitHub, GitLab, Bitbucket, you name it. Then you can export, release and publish this core to a registry like npm or Maven Central and so on. And then finally, the internal code base that using the core right now, right? You're gonna adopt the core that you just published, and you'll drop the old core that you have, and then voila, this is how you're gonna do open source. So as you can imagine, the bulk of the work is going to be in the first step, where you have to do a lot of refactoring to separate the core from non-core, right? And this is where we're going to focus our talk on. Essentially, what this means is we have to make sure where we have core logic, it must not directly reference any non-core logic concept, right? In other words, we want to remove any compile time dependency on non-core in the core code. Luckily, there's a brute force and somewhat mechanical method to do this. Let us introduce you to what we call extension mechanisms. What they are is essentially a pattern, a code pattern, a dependency, a form of dependency injection. And what it does, it helps you at compile time separate the core from non-core by moving the non-core logic into an extension that can be plugged back in or inject back in at runtime, and in order to preserve the behavior before the refactoring. Usually an extension mechanism comes with a few different components, and the most important one is a contract, which tells what the extension does, its action, its input, output. Then you need to provide implementation that act upon this contract, right? And then you need some sort of a glue code that tie what you have in the extension to the actual code that you have where you want to use it. And this consumer code will also load up the implementation that you specify to carry out the action. And finally, you need a piece of code that is called a supplier, which stores and provides the implementation at runtime to the consumer. That's how the thing work together. And because this is a code pattern, what is a better way than just show you the code and as an example? So we have this bit of code right here that used to get the connection from a data source. So you give it a data source, it will try to give you a connection. There's a problem with this code though. Look at this. We have reference to this thing called GS data lake. And essentially that is Goldman Sachs data lake, which is a proprietary concept that we don't want to open source. So how do we use extension mechanism to get rid of this? Now, if you look at the common logic of this function right here, it's pretty obvious that each of the conditional branch of this main logic, the if-else logic right here, is doing a similar job function, right? Which is given a data source, build me a connection. That generic action right there is something that you can turn into the contract. And essentially that's that. We build this, this interface called contract, which gives you a bunch of connection builder. But notice something here. Each connection builder have a different return type, has an optional return type. Why is that the case? Because say if you have a MongoDB connection builder, right? And if you give it a relational database or a GS data lake, it will not know how to handle that. So obviously that has to be optional. Now moving on, how do we use this contract in the code? How are we going to build a consumer code that glue together the connection method and the contract? This is how we're going to do it. Notice a few things here. We put this in the else clause or the catch-all clause of this code. And what it does here is, first, it doesn't change the current behavior. Store that currently support are still going to be supported, right? And then the second thing is, in terms of the mechanism, if you provide a data source that we don't know how to support, right? This code doesn't know how to support. It will try to use the contract and the extension mechanism to look up for a compatible connection builder and roll with it. Now, let's look at how we're going to use these two in tandem and actually remove the reference to the GS data lake. We basically going to implement the contract, provide an invitation for the contract, and look at that right there, right? We create this new plugin called GS plugin that implement the contract. And so somehow at runtime, we're going to be able to plug this back in, and like we already explained, right? In the original code, you no longer have GS data lake, but then it will try to resolve that compatible connection builder from the consumer code. Notice right here, we have GS plugin that implement the contract, and this will be a sweet spot where, we can basically chuck in all the extension implementation with all proprietary features into this plugin. Now let's talk about these two functions that we kind of ignore so far: register plugin and get connection builders. What are they? They essentially come from the supplier code, right? Where at runtime, somewhere on the top level, you have this extension manager supplier code, and you're going to register all this different plugin and extension. And at runtime, these will get injected and be used by your consumer code. So that's how simple it is to install an extension mechanism. And you can go hand with this. Look at the original get connection method that we have. We have a handle logic for MongoDB relational database. Nothing here is stopping you from creating another plugin to handle these guys. And if you do so, your get connection method will be completely clean of any data source specific logic. So, like the gist of it is, if you be able to formulate a contract, a sensible contract for your extension mechanism, the rest of it is pretty easy to roll out. What if there's some case that is a little bit harder to figure out the actual contract? What do you do? So take this example right here, where we're trying to render the header of the application, right? And in here we have a GS logo on the header of the app. In the external version of the app, this is not a desirable behavior. However, inside the internal environment, our Goldman Sachs, we want to show this logo. So what do? We create an extension mechanism that basically have the method to provide render for this logo. So in the GS plugin, where we implement all these proprietary logic, right, we can have a renderer for the GS logo. But in the external version of the app, where we don't have this GS plugin, we don't need to provide any indentation here. It's going to be an empty array or something like that. And so voila, in the external version of the app, you will not see the logo. So really, that's just, hope you had to get the hang of it, and hope you have fun, rolling out these extension mechanisms. And as you start doing this, you start building up and enriching the extension contract that you have. So it's about the time that you can actually start doing some code moving and splitting the code base. We start out with this monolithic web application, right? The code base, everything is probably live under one folder right now. It's called source. So in order to build and set up the monorepo, the first thing you have to do is, pick up package manager, say you're on npm learner or anything like that. And then basically very simple rewrite. What you can do is you reshape this into a monorepo with a single code, with a single module. Let's call this core. Now, next up, you're going to start moving the GS plugin, like the proprietary logic non-core code that you currently have, into internal. And so internal definitely will have a dependency on core. And then you're going to move your supplier code and the app runner, top level app runner logic into this module called app deployment. I mean, don't be too afraid of this. That module is actually very simple. And in fact, sometimes it might just consist of one file that looks something like this. This is how we're going to start the application with the GS plugin registered to it. This is the single file in that module, honestly. And if you look at this instance of the app, right, it runs with the proprietary features that are being supplied through GS plugin. In the external version of the app, we can literally just comment this out. This is the external version of the app that doesn't come with proprietary feature support. And this, if you ping pong these two, these are the two versions of the app that as you incrementally refactor, you have to make sure that they work, each version of this app. So now you end up with the organization of the code base that basically is the final shape of it. You have these three modules. And the job here is, like I said, incrementally bring more logic from core into internal. This process has to be very incremental. Why? Because if you think about it, if something is non-core, everything depends on it must also be non-core, right? And so if you want to move a non-core concept out of core, you have to move all dependent logic on it first to the non-core part. Now, extension mechanism is a very good way to do this, as we have demonstrated, but it's only very good for things like the behavior code that we have just seen. If something is tightly coupled at definition level, extension mechanism might not be the best tool. Let's take a look at one of that example. Here we have a concept called data space, which is a concept that belongs to core, rightfully. But the problem is data space definition depends on service. Service is something that initially we're not comfortable open source because why? Because service is essentially the specification to deploy a data query and then expose it as an API endpoint. Now, we have a few different options here. One of that is something we actually consider is can we open source service? And the answer is yes. Why? Because if you think about the concept of service, it's very generic, right? You just try to have a data query, you try to put it on the API. Sure. But the deployment logic of service is going to be proprietary because they need to know how to deal with all these networking infrastructure and stuff. So that's exactly what we did. We open source service as a concept, but not as deployment logic. The other way to go about this is, classic, just create a generalization of service, a new concept called executable, and use that instead in data space. So that's a very fun way as well to start generalizing code base and separate the code. So with all of that, these are just the two simple decoupling technique that you can use together with extension mechanism to just cleanly separate the code. At the end of it, hopefully you'll be able to separate them cleanly and move the code out and follow through with the rest of the open sourcing strategy that we mentioned before. And so yeah, we're done.
Yeah, nice. Okay. We haven't talked much about a tech stack so far, and that's totally intentional, right? So what is the tech stack that Legend Studio uses? So we use a fairly standard web application tech stack that revolves around both React and TypeScript. But in regards to open source, the two important tools that we need is a package manager that's going to handle the interaction between the different modules and a release automator. So for Legend Studio, we chose Yarn as our package manager and change sets to handle the releasing and versioning of our external tool. JavaScript ecosystem offers a variety of other tools, and we found that these work just as well. But I think the most important thing is our code strategy transcends all these tools. So for an example, in the backend, in Legend Engine, which is the backend of Legend, we use Java, and the tool that we use there is Maven. Maven handles the package, acts as our package manager, and Maven release plugin acts as our release automator. If you want to learn more about our tech stack, both in Legend Engine and Legend Studio, you can follow in our slide deck. So now that we've open sourced, our next step should be how do we maintain the project, scale it, and get contributions, right? So we want to go back to our purpose, right? So our purpose of open sourcing Legend is to get the industry to work together to solve complex problems. So in order to do that, we have to provide external contributors with a stable set of extensions, right? So if we have one clunky extension, that one would be subject to change and it would not be stable. And then when people rely on this and they upgrade, they might risk breaking. So what we suggest is taking this clunky core extension and defining more well-defined extensions that are clearly documented, and users and developers, external developers, can go in and clearly see what methods they need to implement and what contracts they need to implement. So we'll take an example of what On did, right? So he defined a contract interface called contract with 2 extensions, one that touches the logic of building connections, and the other one more specific to rendering of the UI. So these two should be ideally their own interfaces with clearly defined naming conventions, and their methods should be well defined and well documented so that any developer can go in and use them interchangeably, right? So this is just one technique that we suggest that to make your project more scalable and usable for external contributors. We suggest also looking at documentation, CI pipelines to further enhance your project, and those can all be separate talks. So now I know there's been a lot of different animations, so we might have get lost in all that. So we want to leave you with these key takeaways from this talk. The first one is have a clear purpose for open sourcing. Make sure you know what your project is addressing and what field you're open sourcing in. And also identify the quickest path once you do that to separate the core from the non-core part of your project. Once you do that, refactor incrementally and mechanically. So you want to be able to get something out as quickly as possible, and then you can refine that. Decisions that are non-strategical, try to make them as quickly as possible. I would say embrace imperfection and then later refine it, right? So if you want to change your dev tools later, or you want to rename stuff, you want to continue to refactor, you can do that later, right? It's been 3 years since we open source, and we're constantly refactoring and making stuff better, making the extensions more clear for users, creating more contracts, etc. Right? Lastly, but most importantly, you want to have fun. You want to you're putting your own work out there, so remember that. And this process is just the beginning of the journey for you.
So just a reminder, we have a lot of content, but there's so much more that we want to talk about. So we are being a little bit sneaky. We put a lot of those content in the appendix section of the slide deck, so please check it out. Now, I know we just went through a lot of technical content. I know we're running out on time as well, but we can't help but mention this. We are the big believers of if you have a very complicated concept, for any complicated concept, there is a simple, elegant way to explain them. So here it is. We're going to give you a shot of try and describe the refactoring that we did today. So first, think about backup M&Ms, right? If each color of this backup M&Ms represent an extension mechanism that we install, then isn't it that each piece of M&Ms that we have is like an implementation of those extension, right? And so the GS plugin that we had is nothing but a grouping, a handful of those different M&Ms, right? Okay, so let's try this. So now we start with this monolithic code base. Think about that as like a bar of chocolate. Basically, what we did was we melt this down, we make M&Ms, we keep some for ourselves, and give the rest to the community. And that is the essence of the open sourcing a code base. So happy coding, happy refactoring, happy making some M&Ms, and happy open sourcing. Thank you.